In stats, we wrapped up 2 sample proportion tests, or inference. We talked about 2 prop z intervals. So the beginning of that is on the last page. Conditions for this thing are the same as for the test and the hypothesis test in the last video. Our formula looks something like this. Oops. But as it's the case with all the other inference tests and intervals, you can just write the name of it. And this is a 2 prop z interval. All right. So let's dive into this problem about social media. So maybe hit pause and skim through it. We are talking about the true proportion of U.S. teens that use social media. And the true proportion of U.S. adults that use social media. No hypotheses needed because this is a confidence interval. And I see we have 2 samples and they were both randomly taken. So let's say random samples of $7.99 and $22.53. You have to check large counts for both samples. So there are 4 things to check. Remember, we're doing this instead of n greater than 30 because this is a proportion problem. So we plug in $7.99 and 0.8 to get the number of successes, and we get a decimal. It is a-okay if on this step you leave it as a decimal. You're welcome to round it down if you want. But realize we're talking about discrete values, like number of successes. So technically, you should round down, or in this case, on the complement, round up. Just round accordingly. But on this step, like I said, you don't have to. So we go 2253 times 0.69, and we get 1554.6, and the complement of that is 698.4. Both are large. So sampling distribution is approximately normal. And then move to the do step. We are going to do a 2 prop Z interval. If you're confused about Z versus T, we're doing proportions here. And when you have proportions, you always use Z. P1 is 0.8. P2 is 0.69. As you see in the plan step, the number of successes was 639.2, but we need to round because your calculator will not accept a decimal because it's discrete. I would round x2 up to 1555. So if you're confused, you're lost where those numbers came from, look right there and right there and there. And then go to your calculator and get your interval. So on my calculator, I go to a blank screen, menu, stats, confidence intervals, and we want 2 prop Z interval. And we have 639, 799, 1555, and 2253. And we want 95% confidence, so you hit OK. Gives you all kinds of stuff. We want the lower and the upper. We already wrote everything else down. If you didn't write everything else down, write it down. You don't have to write the margin of error or the proportion difference. You don't have to do that part. But it's there if you want it. 07 to 14. So our confidence interval is 0.07, 59, up to 1432. We have 95% confidence that the true difference in proportions I wrote pro twice. What is wrong with me? I thought that word looked too long. There we go, a little better. That use social media and I like to note what I subtracted. I did teens minus adults is within 0.0759 and 0.1432. I want to say one more thing about this. Up in the paragraph, it just asks us to interpret the difference, so we did that. Full credit on this one. Nothing else to do according to what they typed. But they may ask, is the proportion of teenagers that use social media significantly higher than adults? And we do have an answer. So kind of a little bonus statement with 95% confidence. We know the teen proportion is higher or greater. You could say significantly higher, but I think you're allowed to just say higher than with adults, because the entire interval is greater than 0. And yeah, I said I think. Yes, you don't have to say significantly higher, because we're just making a statement on which one is greater. And the issue is, based on the sample, is this 0.8 significantly higher than that one? And it is, off of our confidence interval. So then in our concluding thought, we can just say the team proportion is larger. So I hope that makes sense. You can throw in the word significantly if you want. It doesn't hurt anything to write it. You just don't have to. See y'all later. Bye.